Particulate representations can be used to communicate the structure and properties of solutions by illustrating the relative concentrations of the components and the interactions among them. So for example, when an ionic compound, sodium chloride, dissolves in water, it dissociates into a 1-to-1 ratio of sodium cations to chlorine anions. So because sodium is an alkali metal and chlorine is in the halogen group, these each carry a charge to make this ionic compound electrically neutral. And here we can also observe that the negative dipoles around oxygen face the sodium cations, and the positive dipoles around hydrogen face the chlorine anions. And the relative sizes of the ions and the atoms in the H2O molecule are consistent with the periodic table trends for the ionic and atomic radii. Now in the second example, chlorine is a halogen and magnesium is an alkaline earth metal. So therefore, when dissolved in water, this electrically neutral ionic compound dissolves into a 1-to-2 ratio between our magnesium cations and chlorine anions. And assuming the number of moles is the same in both solutions, then the magnesium chloride solution is a better conductor of electricity, because magnesium chloride dissolves into 3 ions compared to 2 for sodium chloride, and the charge on the magnesium cation is higher. And we can draw the water molecules around each ion as we did for sodium chloride. And for the third example, sodium is an alkali metal, and because we have 2 sodiums, we must have a 2- charge on sulfate to have an electrically neutral ionic compound. So therefore in this case we have a ratio of 2 sodium cations to 1 sulfate anion. And because sulfate is a polyatomic ion, we can see that it has a larger size than the sodium cations.